Well, thank you all. Kee-sun, thank you very much for inviting ABS to participate in this event. What an exciting time in commercial maritime and really global maritime. I think maybe some of us may find it a little bit too exciting. Lots of things changing and lots of new technologies. As mentioned, my name is Patrick Bryan. I'm from ABS. I thought I might take a moment to introduce ABS because perhaps some in the crowd don't know it. ABS has been around for over 160 years, promoting the safety of our mariners at sea. We do this through engineering services, effectively developing rules by which we design commercial vessels against, and then we survey them on an annual basis to ensure compliance with both class and statutory requirements. Today I'd like to give an overview of a few topics. With lots of things going on in the industry, we had things to choose from. Perhaps energy transition, we heard a little bit about that in the keynote. Everything from alternative fuels to nuclear energy. Those of us that are more traditional naval architects, like myself, really like to talk about the naval architecture aspects of what's going on, energy-saving devices, new materials, coatings. But what I decided to focus my remarks on was really the digital technologies that impact shipbuilding as we sit back at ABS and look around the world. So we've heard a lot about artificial intelligence, so why not start there? I think we heard probably very accurately from the previous sessions that AI is really about the consumption of information that is overloading people today, and shipbuilders are no different. For ABS, we write rules that are used to design vessels, and those rules are delivered today in basically a PDF, a book format. I like this particular metric. We count that as 30,000 pages of requirements that great designers need to consume and use to build those or design those great ships. And wouldn't it be great if there were tools that could help engineers and designers today consume all that information and use it more effectively? We started with, when the ChatGPT tool rolled out, testing it just as it's kind of in its native form. And what we learned was hallucination is a real thing. If you were to ask a general AI about requirements, you could get any number of answers. So what we decided to do was team with great shipbuilders like HD KSOE and HD Hyundai to develop a tool called Plato, which allows designers to interact with our rules and ask questions and use them more effectively. We're going even further today to not just use that for the designers, but for the ABS plan review community as well. We're teaming with Seoul National University here in Korea to extract features from traditional 2D drawings and aid the plan review engineer to ensure compliance with those rules. Really some great applications of artificial intelligence. And what we eventually want to get to is the conversion of the rules and the delivery of those rules into the design environment itself. And that leads us to the next technology I'd like to talk about, digital twins. Digital twins really for many people is this nebulous concept that we hear about. The way we think about them at ABS is they are purpose-built to solve a problem and connect it to the physical. The deployment of rules into these types of environments, product lifecycle management technology being premier among them, really will help enable the design of these tools, the design of these ships to be done more efficiently. But it's just the beginning. Vessels that are designed have long lives, and the design basis information that's created in the engineering shops of shipyards needs to extend the long life of the ship. Tomorrow in Brazil, at OTC, ABS is launching our next generation structural digital twin tool called Eagle Twin, where we're taking corrosion information from an active fleet, applying the wastage values to the thinned pieces of steel in a finite element structural model, and assessing the remaining fatigue life and total residual strength of a ship to extend its certification forward. Some really exciting technologies that are not just used in operations, but are born at the shipbuilding stage when that design is initially built. Those initial class CAD models and structural analysis models need longer life, and that's what we see happening in the industry around the world with digital twins. Specifically for safety and compliance, the next generation of digital twins leads us to something that we like to call condition-based class. Many of us, I'm sure, are familiar with condition-based maintenance, basically assessing and understanding the maintenance posture of a piece of equipment, typically rotating machinery, and maintaining that as the machine demands. But that can be extended further for compliance purposes. We believe that in the future, reliance on these types of digital assets will enable better, less costly, better timeliness in regards to compliance, survey, and operation of ships in the future. And again, that all is born at the early stages of design. So getting to a shipyard that has great designs managed in a single place also needs to be thought about in the third technology I'd like to talk about, digital and smart shipyards. We're going to dive into robots here in the future and in the next session, and we are super excited about automation. And automation surely has a very important part to play in shipbuilding as we address the workforce shortages that my colleague, Mr. Kim, just described in the previous session. But there's also room for amplifying and augmenting humans. I think, and we think at ABS, that human augmentation through tools and technologies like augmented reality is hand in glove a part of the future along with automation. In the photo of the surveyor behind me, Angelo Netto, his name is demonstrating a wearable piece of computing to give him information during, in his case, a survey, but it's of course applicable to shipbuilding as well, that precise information at the time needed. The Angelo application on that smart helmet, obviously very similar in technology. From a class perspective, however, the safe use of that technology in an industrial environment is very, very important to us. So we've teamed with Texas A&M University to go explore the safe use of augmented reality wearables from an ergonomics, posture, and situational perspectives, with the expectation that we will be promoting our next augmented reality guide, the first of its kind here within the next year, to allow software designers to put the right information in the head-mounted display to maximize the safety and minimize the risk of using this type of technology in the yards. A couple of points to wrap up on, but certainly autonomy has a segue into the future of shipbuilding as well. Kee-sun mentioned the Prism Courage at the outset. ABS was proud to support that transit. That's the transit of LNGC from Texas to Korea under manned but computer-controlled course corrections. And we were recently proud to certify that fuel savings. So very excited about what that future brings. But that autonomy is not just about the future of ships, but is also a very important part of how shipbuilding is being foreseen from our perspective as well. Can you imagine autonomous machines, robots, moving around a shipyard and performing functions to help produce the vessels? I think we saw some hints of that in the opening, and I know we're going to see some more of that in the end. Which leads me to my fifth and final technology that I'd like to present to this esteemed crowd as something that will change our future together, and that is robotics and remote-based inspection and performance. The image behind me, of course, focuses on flying drones. Drones have been around for a long time and are really the leading edge of the autonomous survey and remote inspection technology thrust that ABS has seen over the last several years. And in this particular case, the drone is equipped with an ultrasonic sensor to gauge the thickness of the steel. That location is then transferred back to a digital twin, a structural digital twin, which then assesses again that remaining fatigue life and structural compliance from a class perspective. But that's just the beginning. We see submerged drones and ROVs operating in tanks, not just tanks of water, but tanks of hydrocarbon and more aggressive things being built and done on the offshore side in particular every day. Of course, we're interested in quadruped robots that can move around, and I think we'll hear a lot more, and I'm super interested to hear from Persona to talk about humanoid-level robotics, bipedal robotics that can be used not just for shipbuilding, but also for survey support and really the operational life of the ships at sea. So with that, I'd like to close with a couple of final thoughts. Something that we say at ABS all the time is that success is a team sport. Something I think when I look around this room, it's not just about companies promoting what they're doing, it's about companies working together and really nations working together. That's why ABS is so proud to participate in this event and all of the APEC events going on this week. I'd like to thank again everybody in the room for their attention and to HD KSOE and HD Hyundai for their invitation today. We couldn't be prouder to support this great cause. Thank you all very much.
Thank you, Mr. Ryan, once again for your careful thoughts and your insights. Thank you. And this time, we'd like to invite Ms. Erin Jungmin Lee, the head of AI strategy team from HD Hyundai, who will be continuing with our presentation. So, ladies and gentlemen, please give her a warm round of applause.
Good morning, everyone. I am Erin Jungmin Lee from HD Hyundai. Thank you so much for being here. As we look at the maritime industries, one thing is clear. The future will be defined by intelligence, resilience, and collaboration between people and technology. Traditionally, shipbuilding has long been a cornerstone of manufacturing, built on craftsmanship and tightly interlinked processes. But today, with a rapidly changing workforce, strengthened environmental regulation, and increasingly complex global supply chains, achieving efficiency, safety, and sustainability has never been more critical. At the heart of this transformation lies AI, a technology that not only enhances productivity, but also opens new possibilities for people and industry to grow together. Today, I'll share how AI is driving a new era of innovation in shipbuilding, with people working safely and effectively at the core. AI is transforming how ships navigate, moving beyond intuition to intelligence. Now, by analyzing vast data, including external weather and ocean data, such as currents, wind, and waves, along with vessel performance indicators like speed, engine power, and historical routes, AI autonomously controls routing and engine RPM in real time for maximum efficiency and safety. It continuously fine-tunes performance, optimizing operations while cutting fuel use and emissions. One example is OceanWise, unveiled at CES 2023 and 2024. HD Hyundai's ocean transformation vision and the driving force behind the future of shipbuilding. Demonstration results across 13 routes and 106,000 kilometers, analyzing more than 1.5 million data points, proved on average 5.3% fuel saving. This is the tangible, measurable advantage that AI brings to shipbuilding and maritime operations. Building on this, HD Hyundai is developing an integrated maritime AI data platform to coordinate complex ship systems from navigation to overall operations. This platform integrates fuel-efficient navigation, autonomous systems, cargo management into one ecosystem, creating a control system that optimizes propulsion, minimizes energy use, and reduces emission in real time. Vessels are evolving into an intelligent system capable of judging and executing optimal navigation on their own. This is HD Hyundai's vision, a sustainable maritime industry powered by data and AI. But technological advancement also requires trust. HD Hyundai's evaluation system scientifically verifies operational efficiency and fuel savings, enabling the industry to objectively validate AI's effectiveness. Ship owners can confirm measurable outcomes numerically, while shipyards optimize designs through objective data. This methodology earned approval in principle from the Korean Register and a statement of compliance from the American Bureau of Shipping for reliability and safety. In collaboration with the MIT Maritime Consortium, that's MIT, ABS, HD Hyundai, we're building a standardized platform that enables ship owners, shipyards, and classification societies to jointly validate AI performance. These efforts ensure the trust and transparency, turning innovation into lasting value for the entire maritime industry. The innovation of AI is expanding beyond the seas, now reaching deep into our shipyards. A new form of production is emerging, humans and AI collaborating through agentic AI. One example is our HD Agent, the world's first AI translation and communication service designed specifically for shipyards. This translation service supports 17 major languages, covering about 90% of the 12,000 foreign workers across our shipyards, most of whom are from the Southeast Asia. In this environment, AI is evolving beyond the support tool. It's becoming a trusted partner, ensuring safe and effective operations. The system has learned 13,000 shipbuilding terms and 4,200 work instruction sentences from the shipbuilding process, ensuring precision in complex environments. It provides real-time supports, like in both text and voice, for work instructions, quality checks, and safety training. Used across shipyards, it improves efficiency, reduces accidents, and enhances worker satisfaction, fostering a culture of collaboration. It enables diverse teams to communicate as one. Come see this in action at the Hallyu Pavilion Shipbuilding Zone right here at APEC. The next step in this journey is the design and production AI master agent, which we call the Myeongjang agent. This agent captures and learns from the know-how of the master engineers, expertise that until now could only be gained through years of hands-on experience. By embedding this expertise into AI, the system can diagnose design and production issues in real time and guide engineers with solutions based on the proven best practices. This is not just automation, it is the creation of an intelligence platform that enhances productivity, safety, and quality consistency across design and production. In doing so, it ensures human craftsmanship continues to evolve, not disappear, in the age of AI. AI is also moving beyond data, now making decisions and taking actions in the real world. Our physical AI research enables autonomous tests such as welding and quality inspections at shipyards with plans to tackle other high-risk operations. More details will follow in the later sessions. By enhancing human capability, physical AI is turning industrial sites into safer and smarter workplaces. For HD Hyundai, AI is more than technology. It's a force that empowers people and reshapes industry. We are building a future where people, industry, and the planet thrive together. With AI, we are redefining shipbuilding for a sustainable tomorrow. Thank you.